We're going to talk about the area and perimeter of similar figures since we've been focusing mostly on area of polygons. So we have one theorem that we're going to deal with today, and we call it Theorem 10.1 because it does not have a special theorem name. So you just need to know the basis of the theorem. It says that the scale factor of two similar figures is a over b, so it's two numbers. Then the ratio of their perimeters is the same, a over b, and the ratio of their areas is a squared over b squared. So let's actually put this into context. The trapezoids are similar. What is the ratio of their perimeters and areas of the smaller trapezoid to the larger one? Well, we want to talk about the scale factor. We're going to talk about the smaller one is 6 to the larger one 9. Scale factor is 6 to 9 or 2 over 3. That means that the perimeter is going to have the same ratio, 2 to 3, because if the scale factor is a to b, the perimeter is also a to b. Our area is going to be a squared to b squared. So 2 squared is 4 and 3 squared is 9. So the ratio of our area is 4 to 9. Let's actually put this into use now. We have two similar polygons that have corresponding sides in the ratio of 5 to 7. What is the ratio of their perimeter and area? Well, if their ratio or their scale factor is 5 to 7, the ratio of the perimeter is also 5 to 7. The ratio of their areas is 5 squared, or 25, to 7 squared, 49. So the ratio of their areas is 25 to 49. So let's look at a second example. The area of a smaller regular pentagon is about 27.5 square centimeters. What is the best approximation for the area of the larger regular pentagon? So here we're talking about areas of two figures. But in order to work with the areas, we first need to figure out the scale factor. So we have the pentagons with side lengths of 4 and 10, meaning our ratio of our sides, or our scale factor, is 4 to 10. That means the area is going to be 4 squared to 10 squared, or 16 over 100. Now I'm going to reduce that fraction to 4/25 because it's a smaller number and in my mind easier to work with. So because we now know the ratio of their areas, we can set up a proportion to find the actual area. So the area is our ratio is 4 to 25. Well, we know the area of the smaller pentagon is 27.5, so we're going to put that at the top of our fraction because it goes with the 4 side lengths, over the unknown area of our larger pentagon with the ratio of 25. So we have 27.5 to the area unknown is 4 to 25. Now we're going to use cross products to solve a proportion, and we get 4a equals 687.5. So the area, by dividing by 4, we get the area of our larger pentagon to be 171.9 square centimeters. Let's look at another example. The area of two similar rectangles are 1,875 square feet and 135 square feet. What is the ratio of their perimeters? Well, we're dealing with area here. An area is a squared to b squared, and we want to get to a to b because that's how we find the ratio of their perimeters. So we have a squared to b squared equals 1,875 over 135. So we're going to square root a squared and b squared because that'll give us a and b. So when we square root 1,875, we get 43.3. And we square root 135 and we get 11.6. So the ratio of their perimeters, or a to b, is going to be 43.3 to 11.6. Now I want you to try these two examples. Look back at your notes if you're confused, but give it a shot, pause the video, and come back when you're done. So the scale factor is 3 to 4, which means the area is going to be 3 squared to 4 squared, or 9/16. Now we know the area of the larger one, so when we set up our proportion, 9/16 is equal to the area of the unknown over 96. Using cross products, we get 16a equals 864, and the area then becomes 54 inches squared. So we know the area of the smaller polygon is going to be 54 square inches. Now looking at the second one, we know the areas are 50 to 98. And we know area is the a squared over b squared. So we need to get it a over b. But before I square root them, I actually know that I can reduce 50 over 98 to get 25/49. Now if you didn't do that and you square rooted them, that's okay. But it'll work out a lot nicer because I can easily find the square root of 25 and 49. So when I square root both, I get a over b is 5 to 7. Now your ratio will be the same if you just square rooted 50 over 98, but it won't come out as nice and clean. It's still the same ratio, but if you can reduce things, especially when you can find perfect squares, that'll make your life easy. One more application to this. The scale factor of the dimensions of two similar pieces of window glass is 3 to 5. The smaller cost is $2.50. How much is the larger piece? Now when we talk about $2.50, we're talking about area. Because when you buy a two-dimensional piece of glass, you're buying it by the area, by the size, not by the perimeter. So we know our scale factor is 3 to 5, but we actually have to talk about the area here, which is 9 to 25, or 3 squared to 5 squared. Now again, we're just going to use a proportion. Our ratio is 9 to 25, and we're paying 2.5 or $2.50 for the smaller one. How much is it going to cost for the larger one? Cross products gives us 9x equals 62.5. So our larger piece of glass is going to cost $6.94. And that's it. You made it to the end. If you have questions, please bring them to class.